So Dr. Olu earned a PhD in space geophysics from the National Institute of Space Research in Brazil. He briefly served as an associate research scientist in the NPE astronomy division before moving to the United States. There he continued his research as a postdoc associate at the MIT and later as a postdoc fellow at NASA's Jet Propulsion Laboratory for the highly competitive NASA postdoc program. Yes, good. So currently, Dr. Jonah is a research engineer at the Stanford Research Institute in California. He has participated in various space science projects and has special interest in the physics of the ionosphere, GPS positioning, and measuring accuracy, space weather, storm time effect, and the vertical coupling of the whole atmosphere. His work employs MEL models, physics-based models, and measurement from both ground-based and spaceborne observers. Thank you very much, Dr. Olu, for joining us today, and we're very eager to hear from you. The floor is yours.
Thank you, sir. Can you see my screen?
Yes, you can.
Oh, okay.
You can see your screen, but it might be another desktop because it is just the background right now.
How about now?
Still the same thing for me, at least.
Oh, okay. Let me see why.
You have to share. You have to share everything.
Yeah. I'm not familiar with this thing.
That's why you're here.
Let me see. I will share and then share again. So it said screen. So if I share my screen, what about now?
Yeah.
Yes. Yes.
Excellent. That's good. We are getting there. Right. So hello, everyone. Sorry for lateness. I was waiting on the door for someone to admit me, but so that was why I'm late, a little bit late. So I missed all the presentation, but that's okay. I'm going to talk about our effort on CONGA, and CONGA is the development of GNSS receiver over Africa, Equatorial, and Low-Latitude region. And we have been on this for a little while. I have a lot of collaborators on this meeting today. And Dr. Baton Rabiu, I just heard his voice there. And he has been one of the collaborators and contributors in this project. And I'm going to be talking about what the CONGA network is, the objective and justifications for this, what is the network distribution, the mechanical design that we are working on, electrical designs, just showed all of these figures. And then what are the scientific applications that this can bring to the community. And then we also have challenges, when you want to put something in this region of Africa, you have a lot of challenges that you have to militate against, they are militating against you. So, and then I will show us some of our, our progress. So why are we doing this? When you look at the global map, you see that region that shows the dimension of each continent at the Equatorial region. And we see that the African region has a larger region in the Equatorial region. And there have been very little or no ground-based instrumentation here that could commensurate with the large area of these continents. So this is one of the things that motivate us, And CONGA is about building, strengthening, training and development opportunities for students and local researchers. It's about scientific research, and it's about supporting advancement in space weather, climate monitoring, and improvement of signal processing, nowcasting, as well as enhancement of atmospheric and spheric modeling. We have open science in this, or CONGA will bring up open science. And as we know, if you have been part of our meetings, we are very supportive of data accessibility everywhere. So like I was saying, this is the distribution of the GNSS receiver. That is what at least we can have at the time I make this plot 1 year ago. And you can see the distribution over the African sector. When you remove the network from South Africa, you only have less than 20 GNSS receiver. Yeah, people will tell me that maybe there are so many other receivers, but these receivers are not made available. The receivers that are made available are just 19 over the African sector, not including South Africa. When you include South Africa, you see 122. And to bring it into more perspective, look at this other map that shows the number. You have the landmass in blue and the GNSS receiver, ground-based receiver in red or orange. Now, over North America, you see that percentage is 65 compared to the landmass or land area of 29%. Now, if you go to Europe, you see that huge ground-based receiver as well, and the landmass is just 12%. And over South America, something similar is there, but it's a little bit fair, right? But when you look at the African continent, I think in this calculation, we have the largest landmass over Africa, and we have more or less nothing to show for that in terms of Equatorial region ground-based receiver or ground-based receiver of GNSS receiver in the whole continent. We have only 2% compared to the landmass that we have. I know there are some challenges that people will want to bring up, but this is what the reality is. So these are the things that we saw as a problem, and we decided to bring it to the table. So now you want to ask me, why do we need GNSS receiver? Besides, I'm going to talk more about this, but this map shows us a quick picture of why we need GNSS receivers. Everybody knows the importance of TEC, total electron content, and it helps us to understand so many things. We can study seismic activities, we can study wave activities, we can study plasma bubble, we can study scintillation, all on TEC. And when you look at the behavior of equatorial ionization anomaly over South America, you will see that clear trough and crest of anomaly. If you want to look at what is going on over Africa, you need to find maybe some modeling to help you, and if there is no data, model is also not really capable, right? So that is a major problem right there. And this is just one aspect of what the GNSS ground-based receivers can do over that sector. We also have different other areas. When we send out survey, we expect scientists, we expect researchers, we expect professors of schools, universities, but we also have geologists, surveyors. We also have government enterprise, filling that form. That shows you the urgency of these receivers over that region. Now, this is the plan. We have the plan to have a well-distributed GNSS receiver over this region. And the figure you are seeing here is not just imagination, it's specific region and space, location in those countries. So this takes a lot of work to do, but we get it done. And this image shows that we can actually put a receiver on that point. So that is the good news, because people say this is a desert and that is why the receivers are not there, but they are not all desert. We can put receivers over this region. And we also have other good news, right? Now, these receivers will be 280 receivers. We have over 28 countries around the low latitude and equatorial region of Africa. And then the good news that I said we have is that you don't even have to worry about power or internet at some point, depending on the kind of grant that we are able to get for this project. So the instruments or the units will be 100% solar paneled, and that is also sustainable energy, right? So that is the good news. Now, we are not folding our hands. We have started something. We've started the design. This is we call it GRU mechanical assembly. And this shows that we are not going to rely on internet. We're not going to rely on electricity, which has been dragging people backwards. So this is the setup, and this is the electrical setup or the instrument electronic setup. So all of this has been in process because we get a little bit of fund to start something first from my company, and then we can launch that to a bigger agency that will be willing to fund these projects. So even though this project is very famous, everybody knows CONGA, and we usually have monthly meeting. It is not yet in process. It is not yet activated. We are still waiting for funding. So if you are here today, you are part of that sector that will help us. If you have questions, please bring it up and we're able to answer your question here. So, but we are soliciting for your support to fund this project. Now, like I said, all of these things that I'm going to be showing are what the basis of what I've said before. This is the science or different application by which we can apply CONGA. We have space science, we have navigation safety, we have advanced technology, and the list goes on. You can see those space science and those applications, they also subdivided into various other aspects that could be benefiting from CONGA. And I won't go through each one because of time. Now I also have because I told you there is TEC, but TEC is just one aspect. There is also different thing that you can do from this distribution. You can do scintillation, you can do plasma bubble, F region regularities is there, and this. People know about all of these things. People tell me, oh, I know about F region regularity. We see that a lot in Africa, but how are they generated? What is the long-term variation? There is no data to show us all of those things. And if they are South America, we see a lot of data there. We don't know where the sources are from. Maybe they are from the African sector. This is a kind of stepping stone that can also bring other projects on board. People can start studying, and the students and researchers have better statistics over Africa to understand what the global effects of all of these problems are. Now, this is not without challenges. Like I said, we have a lot of challenges. We have lack of supporting infrastructure. We have epileptic electric power supply over the region. We have security of facilities, poor internet, and the list continues. You see, political will. These are problems. and no interest in science. There are some African countries that we tell you we don't need this, right? All of these are problems. We have customs, clearance, trust. Trust is a big one. And that is why we have CONGA meeting series in order to build that trust. That is one of the things that we are doing. And there are some other solutions. We can provide provision for basic infrastructure. Basic infrastructure. You tell me what are you going to provide for basic infrastructure, Olu? Oh, well, we are at least providing a unit with a solar panel. We don't need electricity. We don't need internet. So that is a kind of provision already. And then we have character check, trust, allies, satellites. All of these can be provided, right? Awareness can be provided. Capacity building, yeah, that's important, right? Capacity building is one of the things that we're going to be providing along the line. So the list is there. The solutions are also there. The mitigations are there. And we are still working on more solutions to mitigate all of these challenges that we have. So it is not all roses, but we have it to a starting level that we know we can achieve this mission. And more to that is, I think this is my final slide, so I think I'm on time. So more to that is that we have started a survey, and that has been going on for a while, and that shows a lot of interest in the community for this project. As you can see, we have more than 18 African countries that have signed up to this survey, and they participate in the meeting every month. And we have 70% of African countries, and other countries are 30%. That is what we need. We need to know if the place that we are putting instrument, they have interest in that project. And that shows that a lot of interests are there. We have people that filled our surveys are students, researchers, lecturers. I also have a small percentage of government agencies, So everybody is interested in the project. And finally, let me just say that if you want to be part of our CONGA efforts, please scan this barcode and you can complete the form. And we also have our YouTube channel, all our talks. We conduct very educational meeting every month, and we put that on the YouTube. So you can always go to the YouTube channel to get more information about that. And that will be my presentation. Thank you. Thank you for the opportunity.
Oh, thank you. Thank you very much, Olu. Thank you very much for all the good work you are doing for Africa.
Thank you.
Is there any question or comment for Dr. Olu?
There was 2 questions in the chat. Maybe I might attract the attention to the second one first, because the first one could be answered asynchronously. The second one was from Agnes. Professor Olu, can you please provide more information on the satellite internet you plan to use?
Yes, that's a good question. We have various satellite internet that we want to use. One of these is Starlink, one of these is Iridium, and these two will depend on the kind of funding that we have. So, and we also know that it's not all the places over the African sector or that region that we're proposing is having internet challenges. Some places, universities, they already have internet that they use in day-to-day. So we don't need internet Iridium, because people say Iridium is expensive or Starlink is expensive. Yeah, it's expensive. So but we need to get it done. If we send one satellite to space, it's over Africa, right? And then we spend a lot of money to do that. So we can also get this done to benefit everybody, both the African region and outside Africa. It's going to be global benefits as well. So I think it's what we can do. And we have everything under budget. We just need people the agency to show more interest on this project.